Hello, everyone. Welcome to our talk today. So today we will talk about the progress for distributed storage on Arm64. I'm Kevin Zhao and Xinliang Liu today. So we are both from Linaro LDCG, vertical group LDCG. So we are focusing on the distributed storage development on Arm64. Yeah. Today's talk, we will have three parts. So first, we will cover briefly introduction on the software-defined storage project. It is a Linaro open project, and it is a collaboration project with our members, and we will contribute to the upstream. And in the second part, Xinliang will introduce the different software-defined storage project progress. So we have picked up several storage open source project and contributing to the upstream. And in the last part, we will share a storage ecosystem landscape. So it is a very easy entry for the developers and the users to seek the newest up-to-date information on the storage for Arm64 platform. Okay. Yeah. Regarding with different open source software-defined storage project, so for generally end user or upstream developer, you may have several questions. So does it has supported Arm64, and does it have the Arm64 release? And also in the further, if they have the Arm64 CI, and after the enablement side is finished, the next part is what is the performance on Arm64, and is there some better practice, some adoption or the best practice on Arm64? So there are plenty of the projects, and also there are plenty of the questions here. So we have actually, it is very hard for upstream or the end users to pick up the newest information and the up-to-date informations. So there are several problems there. So at Linaro, we have set up a enhanced software-defined storage project on Arm servers. It is a collaboration project, and we have worked with our members to targeting for the generalized software-defined storage project and the relevant acceleration lib. So our methods are just, we will have two steps to do the development, and also we will have our information display. Yeah. So generally for a open source enablement and optimization, we will have two steps. So first is we will set up we will doing the enablement function validation to different project, to different software defense storage project. And on top of that, we will have to optimize the framework on Arm64 by leveraging different acceleration lib and the different newest Arm extensions to boost the performance, to make it comparison with x86. Yeah. So we know that on top of that, some of the open source projects has been enabled and verified, but for the upstream or for the developers, yeah, or the end user, what they want is they need to have a very uniform display to get all the detailed informations. Yeah, because each of the information seeking will cost a lot of time, and maybe they are not very accurate. Yeah, so at inside this project, we will have our information display. We have collaboration with the another Linaro project called Arm ecosystem landscape. So we have maintained a sub page called the storage ecosystem landscape. So I will show the detailed information on the third part. Okay. And we know, yeah, for storage, there are plenty of the projects, and we have picked up some of the famous projects according to our investigations and survey with our members. So we have picked up some famous projects as a pass one to do at first. So you can check below the sheet. We have picked up several we have picked up several common distributed storage. For example, the Ceph, Lustre, and also for the for Rook, Longhorn, and Mayastor. So both of them are the newly cloud native projects, and they are actually means the new storage using method in the cloud native world. And also, we know for different projects, the acceleration leap is very important. So we have picked up some projects called, for example, SPDK and PMIME to boost the performance. So previously, our member company, for example, Arm HiSilicon open source team has done a lot of the work before. So for example, the SPDK and Ceph. So we will generally track some status on our ecosystem landscape and leveraging the SPDK and the PMIME to optimize the common file system, the common storage system. Yeah. Okay. Okay, next I will hand over to Xinliang. So he will talk about the more detail for the different project progress.
Okay, thank you, Kevin. And let's go through the status and progress one by one. Okay, the first one is the Ceph project. So what is the Ceph? Maybe most people know it. Ceph is a distributed object, block, and file storage platform. Before we touch this project, the previous status is Ceph community has Arm64 released already. It is widely used in some private cloud. Ceph Crimson already cannot build on Arm64. And of course, no CI support, including the PR, podcast matrix test, and the integration test. Next page. And now the status and progress we have made are, we made the matrix CI support on Arm64 per PR, per proof test, and we also maintain the Arm64 matrix CI failure. And we fixed some UT errors and build errors of the Crimson OSD. This picture shows the matrix is running every PR in the upstream GitHub repository. Okay, next. Okay, this is the load status and progress. And also, what is the load? Load is an open source cloud native storage orchestrator for Kubernetes. It providing the platform flavor and support a diverse of set storage solution to the natively integrate with cloud native environments. And the current status is Ceph, MS, and Cassandra backend storage provider have Arm64 list already. We also verify Ceph storage provider deployment and functionalities and found that no big issues. And we also work with the upstream guide to add the Arm64 Ceph currently integration test to the CI. Inside this test, we donate one GitHub Action Arm64 runner for the test from our developer call. And this test run on top of the latest clean Minikube Kubernetes cluster. And it will do the master build deployment and Ceph cluster status checking test. It is run once every day at night. And this picture shows it is running every day, and it is run more than 100 days already. Okay, next. This is the Lustre project data. And also, what is the Lustre? It is an open source parallel file system that supports many requirements of the leadership class HPC simulation environments. The current status are there's no community Arm64 released yet, but the Arm64 client with 64 server test already in the CI. And also we have verified Arm64 build and basic functionalities in the local environment. That's including verify the Lustre build on CentOS 8.4, verify OpenSysFS build on CentOS 8.4. We also verify server and client all in one for the file read-write functionality, and also the multi-nodes. And we have also verified both OpenSysFS and LVC OST file systems. Okay, next. And we also reached out to the Lustre community team about the Arm64 release. But unfortunately, they have no plan to release Arm64. And we're told that a few Arm64 failed tests should be fixed first. And we found that many of the Arm parts relate to the 64K page size. You can also leave reference to the last Connect Lustre session for some other status. Here's some to-dos before the Arm64 release happened. The client is test and should be okay, and many words are related to the server end. And we should fix some Arm64 issues. And a complete test of Arm64, including the server end. And we also maybe need to add the Arm64 server MCI. And then after this thing we may maybe talk to the community and wait for them to have a plan to release the Arm64. Okay, next. And this is the BFGS project status. So also, what is BFGS? BFGS may be the new parallel file system. It is hardware independent and developed with a strong focus on performance and designed for the easy of use, simple installation and management. BFGS is designed for all performance-oriented environments, including HPC, AI, deep learning, and other new use cases. The current status and progress are: there's no Arm64 released yet, and we verify Arm64 build on CentOS 8 in the local environment, and we encounter the client cache on ARM v8.2 plus hardware. This is the issue about kernel copy from user cache. It is related to the PAM and UAO feature. And we have find the root cause and send a draft patch to the user mail list for review. And according to the comments, we need to define and adapt the patch to the new 5.11 kernel. And here's some to-dos before the Arm64 release happen. We need to fix the client cache issue first and other file Arm64 issues. And maybe a complete test on the Arm64 and also add the Arm64 CI. And then wait for the BFGS everything to have a plan to release the Arm64. Okay, let's welcome my teammate Kevin to present the last part.
Okay, thanks Xinliang for the detailed introduction for the some of the projects. Yeah, so as Xinliang referred, so we have a contribution to some of the software-defined storage project, and much of the efforts are putting onto the for the Ceph upstream CI, the pull request CI, and the Lustre, BFGS enablement and bug fix. So and also we have aiding the support for cloud native project Rook, the Rook CI. So and in the last part of this project progress, so I will share some information about the acceleration lab. So we have contributed some we have make some contribution on the persistent memory. So it calls the PMDK, the persistent memory development kit. So that project was firstly being created by Intel for their Optane Intel Optane SSD and NVMe device. So but we are happy to see that after the ARM v9.2, the DC CVAP instruction has been added to the ARM CPU, and now it has supported the persistent memory functions, and the persistent memory device, we can get a persistent memory device now by the QEMU emulation of a virtual machine. So that would be very easy for us to do some enablement first for the PMDK, and also using the PMDK to in some user scenario, for example, the Ceph RBD cache. And we can see that by ARM open source team has contribution to the ARM CI, Arm64 CIs for PMDK. So that will be very good to hear that. So here, besides I listed some PR we have done to support this function. So each of the mainly are focusing to support the DC CVAP instruction for the data cache flashing. Yeah. So the Lustre is a limitation for this PMDK now, because due to the kernel limitation, it is not supported the device DX support. So all we have is a file system DX access. So you can, but the advantage is we can leverage this FSDX to running the PMDK, and by mounting the persistent memory as a DX aware XFS file system or ext4 file system. Okay. Okay, so let's come to the last part. We can see that for one project, we know for a storage project, maybe inside our scope, for example. So you may have several questions. So it has support Arm64 or not, or it has optimized or not, and do they have some best practice or adoption? yeah, in the production. So a bunch of the questions you have, and maybe there's a question is there a place to hold all the detailed information here for the software-defined storage project status on ARM64? So that's why we have running this style page on the ecosystem landscape. Yeah. So we have actually grabbed a lot of the projects inside here, and we will have, for each of these projects, we will have a sub-page to tracking the different project. So we have generally divided to 3 parts. So first is the distributed storage. We can see the very familiar projects, Ceph, Lustre, and something else, right? And in the middle part is the cloud native storage, and also there are some cloud native projects for the storage and the database, for example, the etcd or RocksDB. And in the right part, that is acceleration libs for the DPDK and SPDK and etc. Because yeah, so there has been some file systems already need to be tracking the status. Yeah, so that is a general information we want to seek and gather the information. And as I refer, so the ecosystem landscape is working in progress. So we just have one demo here, I will show. So we take the Ceph as a reference. For Ceph, we will have a general introduction on the first on the top, and we will have and if you want to have the Ceph supported release on ARM64, we have already listed for you here. So by clicking each link, you will get you will be rotated to the release page, and you can see more information there. So, and the project's CI status, we will tracking on the Ceph PR CI status. So you can by clicking to jump into the Ceph Jenkins to get more information. And besides, we have work items. So that are the working items are mainly what we have done on the Ceph upstream PR or the Linaro or our Linaro store project. I refer, we have launched this. There has some Jira items there. So that is a totally open Jira. So you can click to see the currently development status there. Yeah. And the last part you can see, so there's a news and events. We have tracked all the Ceph on ARM64 status on the related sessions. So if you want to get some basic information or the up-to-date information support, so that will be a good entry for you there. Okay. And as a Linaro open project, we welcome the collaborations. So because we have just pick up some story project first as a pass one to work on. So, and according to our members and upstream status, but we know that we are not have the sufficient knowledge to understanding the production or the upstream, the deeply upstream status. So maybe some of the project is very important and we have not picked up there. So, and maybe you have some more ideas for the optimization or some questions to ask. So we have listed 2 methods. You can contact it, and we can have a discussion there. So first is a open mail list. You can register and send email there for discussion. And also, if you want to the instant messaging, we have set up the Discord server called Linaro community, and there's a channel called distribute storage. So you can just click here to join the channel, so we can have more discussion there. Okay, I guess that is all we have covered today, and thanks everyone for listening to our talk, and wish you have a good day. Thank you.